A 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, what will be the peak value of the displacement current? To solve this problem, we need to analyze the situation of the displacement current in an LC circuit. We are given a resistance of R is equal to 100 ohm, a capacitive reactance XC is equal to 100 ohm, and a source voltage which is 220 volts, and the capacitor which is 50% charged. Let us first determine the total impedance. And the total impedance Z of a series LC circuit is given by the formula Z is equal to square root of R square plus XC square. We have the values of R and XC. On substituting, we get square root of 100 square plus 100 square, which is equal to square root of 10,000 plus 10,000, which is nothing but square root of 20,000 equal to 100 root 2 ohms. The current in the circuit can be found using the Ohm's law given by IRMS is equal to VRMS by impedance Z. Given that the voltage source is 220, on substituting, we get IRMS is equal to VRMS is nothing but 220 divided by impedance 100 root 2, which is equal to 220 by 141.42, which is approximately equal to 1.56 amps. Now, the peak current I naught is related to the RMS current by I naught is equal to square root of 2 into IRMS. Substituting the value of IRMS, we get square root of 2 into 1.56, which is equal to 2.2 amps. The displacement current is equal to the current in the circuit. Since the capacitor is 50% charged, we are looking for the peak displacement current when the current is flowing through the circuit. Thus, the peak displacement current is 2.2 amps, so the correct answer is option C.